So, our first session, our first speaker in the second session is Professor Cameron Neylon. And Professor Neylon is Advocacy Director for the Public Library of Science, a research biophysicist and well-known educator for opening up the process of research. He speaks regularly on issues of open science, including open access publications, open data and open source, as well as other technical and social issues of applying the opportunities of those devices. Some honors have been bestowed on him. He's a SPA innovator of July 2010 for work on the quantum principles, and is a proud recipient of the blue obelisk, whatever it is. Is it really blue?
It is blue.
Oh, good. A blue obelisk, and most important, for contributions to open data. He writes regularly at his blog, Science in the Open. So please take the floor.
So thank you, the organisers, very much for the opportunity. It's always a great pleasure to follow the talk by Stephen, not so much always necessarily a pleasure to go before him. So if you're ever organising a talk and you get both of us to speak, I recommend that you throw a dice, because otherwise we'll disagree about who gets to go first. That said, I want to start by emphasising that there's much more that we agree on than we disagree on. And hopefully I'm going to tease out those agreements along the way. I'm not actually going to talk very much about open access at all. I am going to talk about open science, and I'm going to try and make a case that this isn't overreaching, because the difference in our perspectives, I think, in part comes from the fact that Stephen was really at the beginning of this process, saw the potential really in the middle of the 1980s, and has been fighting for that potential to be realised ever since. I came to this more recently, and I came to it not from a question of access to published papers, but to some extent from a specific experience of my own through interacting with other researchers on the web. I'm actually bypassing the research literature entirely. And what I want to do is articulate some principles and some thoughts about how we can think about the principles that tell us how we can advance research effectively. To identify those principles that will help us navigate this path. And I think one of the other points where we differ is the notion that this is a stepwise path. I would argue that one of the reasons why we haven't, over the last 20 years, made as much progress towards either gratis or libre open access is in part because we haven't addressed the direct needs and incentives of the researchers themselves. And that in some ways what I'm going to present to you is a dream, and you may see that as overreaching, but embedded in that dream are opportunities for self-interested researchers to take advantage of the opportunities that the web brings in a way that takes us closer to that ultimate world. So I've adopted some of the story from Michael Nielsen's book, Reinventing Discovery. I recommend that very much as an introduction to this kind of space and some of the background literature in the way of thinking about this. I also will touch several times on the questions of networks, how networks behave, and how we can use our understanding of how networks behave to understand where the potential lies. So I'm also going to start with the question of what do we mean by open, what am I talking about? And very frequently when we talk about open, we're talking very often about unlocking the key, unlocking access to things that we have already created. But if we talk about that, what do we mean when we use this word open? It's a very contested term, as you already heard. People use this term in different ways to mean different things in different contexts. And all you've heard about is disagreements about what open access means so far. So let's focus first on this question of sharing what we already create. I'm going to pick two definitions to start with. One is the open source definition, which is the originating place where this use of open was. And the open source definition talks about access to the source code behind computer programs. And it makes this point: the license must not restrict anyone from making any use of the program in any specific field of endeavour. That was developed by the Open Knowledge Foundation to into something they call the Open Knowledge definition. And it talks about the license must not discriminate against any person or group of persons. This notion of non-discriminatory access is very important, and is an ethical underlying principle of a lot of this discussion. As Stephanie intimated, I am going to quote Budapest Declaration, as I often do, but I want to pick out a few of those key points. Again, any users allowing access to use for any lawful purpose, without barriers that are inseparable from those gaining access to the internet itself. So when I use the word open, and again I agree, it's perfectly accepted, this is a contested term, but in the way that I use it, I mean that anyone can use and access these things for any purpose. But there are no restrictions on fields of use, on geography of use, on the kinds of people who can use them. But that's only part of the story, because there's a bigger thing here which the open source movement can teach us about the underlying philosophies that are working here. And we have to ask the question, not just what is taking stuff that we have made and making it open, but what can we gain from being open? And I want to sort of illustrate this with just some thinking about what this means. So for me, what we're fundamentally saying is that I've done some work, I've created some resource. Again, I'm not talking about papers yet, I'm not talking about data yet, I'm just talking about the nature of an intellectual effort. I believe that work can help someone. Hopefully that's the case, or you wouldn't be doing it in the first place at some level. Certainly it would be unlikely that anyone would be funding you to do it in the first place if it was purely of interest to you. So, I'm a physical scientist by trade, so I tend to resort to equations even when they're made up of ones like this. Yes, I know this. For anyone who's actually into network modelling, I know this is very simplified. We can have a discussion about debating it in micro-model later. But the point I want to make is that the probability, the chance of us helping someone, of our work being useful to someone, is a function of three things, roughly speaking. Firstly, the proportion of people out there who could use your work. Your work is going to be of a particular nature. There's going to be a limited population of people who are able to use it and to apply it. It's a function of the usability of your work. And that means both the ability of someone to find it and discover it, but also their ability to read it, to interact with it. The distinction is in the right language, is in the right form of language for a particular kind of use. A research paper is not perhaps much used in a kindergarten. Is it structured in a way that the elements you created can actually be reused? Is the code, is the process modular? Are the materials required to make use of this available? Is it usable? And of course, the critical question that I keep coming back to, the number of people you can reach. This is what the web changes, the number of people you can reach, the difference between the print world and the online world. So we have this fraction of interest, friction, and numbers. But there's another aspect to this, which is that we haven't yet really talked about, and this is where the real power starts to lie, is the notion that there are people out there with expertise, with interest, and again, I recommend Michael's book, who goes into this in detail, as does several of Clay Shirkin's recent books, that can help us. This is the story about citizen engagement in research. This is the story about creating new collaborations, new networks, of building research networks that are bigger than the sum of the components that make them up. And there's again, I think we can apply in many ways the same kind of thinking, the same kind of equation. How many people out there are there who could in theory help you in some ways, who could in theory contribute in some ways to the work you're doing? How easy do you make it to contribute? If you've not told anyone you're doing this work, then it's unlikely anyone's going to come to you and help. If you make it very difficult to contact you, or to discover that you're doing that work, or to contribute in an open source kind of environment, those things make it difficult for people to contribute and reduce the chance that anyone will. And obviously, again, the number of people you reach, the number of people who are aware of what it is you are doing, the number of people who can reach back to you is a very important factor. And again, this is what the web changes. It used to be the case that you could pick up the phone or write a letter or go to a meeting and talk to 100, maybe 1,000 people. There are 3 billion people with access to the web in one form or another. You only need a very, very small proportion of those 3 billion people to be interested in what you're doing for that to still be a large number of people. I'm going to argue for the point of simplification that, again, I appreciate for the network modelling people out there, this is a terrible simplification. The number of people who are actually going to be relevant to a particular discussion, I'm going to argue, is roughly speaking this. You need to make that friction term as small as possible, to make it as easy as possible for people to use your work, to make it as easy as possible for people to contribute to your work. And you want to make the number of people able to make that connection, the number of people able to discover, able to read, able to interact as large as is possible. So my argument is that being open is acting to reduce friction and to maximise end. That's actually all there is. But I also want to make the point, it's not just about throwing stuff over the fence. It's also about thinking about how we enable this for incoming information. How do we make it possible for people to contribute? I am, in many ways, a child of the beginning of the web, or perhaps I'm in one of that new generation. I can barely remember non-electronic cash registers, but I can remember the world before email and mobile phones. But my academic career grew up at the same time as the social web did. Again, I'm coming perhaps from a different kind of space. So why does this matter? Why is this conversation happening now? Why are we having these conversations now? And we didn't have them in the 1960s and the 1950s, because surely there were people who wanted to contribute, there were opportunities for people to have access back then. But this seems a new-ish conversation. And the answer is that the world has changed. You've already seen this diagram. This is the emblematic diagram that illustrates the World Wide Web in any of these kinds of talks. We have a digital network infrastructure that is entirely different to what we had before. And that's what makes this conversation possible. That's what makes all of these different conversations possible. Because we have this ability to reach many more people with much less friction than was ever possible prior to 1995, or prior to 2000, prior to 2005, with the advent of the read-write web. But even then, why does that matter? Why does friction terms, why these end terms matter? I'm going to show a video, this is a simulation of a network, and I just want to use this to kind of illustrate some points about the characteristics of networks. And again, this is where I somewhat differ from Stephen in this notion that there are only very small, specific groups of people who can read, who can benefit from access to research literature, and that it's impossible to make big differences by taking partial steps in different directions. So this is a simulation of a network, and what I'm doing is increasing the connectivity of the network. The network itself is random. I'm running the simulation several times. Over on the right-hand side, I'm showing two things. One is the number of clusters. If you like, think of this as the number of different separated communities who haven't yet made contact, or the number of different disciplines that maybe have increasing amounts of access to their own literature. On the bottom, I'm showing the largest cluster, so the largest N. So again, remember, I'm talking about being open is maximising N. How many people can you reach and how difficult is it to reach? As you might expect, as you increase the connectivity of this network, the number of clusters rises for a while, the small ones form, and then it drops as you create a larger cluster that spans the whole thing, where information can freely flow across the whole system. The largest cluster starts off very, very small because these are small clusters. But suddenly there is a transition point. There is a point of criticality where suddenly you go from very poor connection to almost complete connection, where the nature of the environment changes. But there's another point here. These sharp transitions, these are random networks, randomly simulated. And yet each time I run this simulation, that point of transition happens in the same place. It happens in a predictable place. Now, we don't do science on a square lattice network. We don't exist in a simple world where we can just change the overall connectivity. Our lives are much more complicated than that. Our interactions in the flow of information is much more complicated than that. But the point I want to make, and I'm going to give some examples, is that successful open projects show this behaviour where there's a sudden change in the behaviour of the system, a sudden change in capacity of the system. And nothing happens for a long time, and then it all changes. And that if we could understand the complexities of the network in which we are working, if we had better models, data and systems, we would be better able to understand and predict exactly where the resources that we need to place in different contexts and different disciplines for different kinds of research outflows, for different kinds of research process that would allow us to see the kinds of benefits that I'm going to use some examples of. So my argument is that there's massive potential, but, and again, there's a very broad agreement on this, we're certainly not there yet. We have this new technology, but we really haven't figured out how to use it properly. Exactly the same people way that when people first came across the electric light, they tried to light them with candles and didn't realise there was this switch by the side of the door that you could turn this light on with. That's basically what we're still doing with the internet. Someone was saying in the meeting yesterday, we're still in the faster horses stage. We have not got to the point where we have the Model T. But my basic point is that we hold a public trust. We hold a trust both from the communities that support us as scholars and those who fund us as scholars, both public and private funders, for mixed and applied and pure research. And the simple argument is we can do better. We can do better at discharging that trust. That's all that really matters. The question is, what is the best way to do better at discharging that trust? And that is obviously when we get to the point of implementation, we do have disagreements on the different paths available to us. So why does this matter? Well, it matters particularly for science because as a globe, we face a few challenges: environmental, ecological, health, political, economic. We have a lot of things we need to sort out, and we need to sort out a lot of them pretty damn fast. So we should be getting to work on that. And I'm not going to say anything more than that, but to say that again, we need to work on these things. So a core question then is, if we move in this direction, what do we enable? What changes? And I'm going to give you some examples of projects. They're not about open access. They're also not flying cars or jetpacks. Those things. These are things that have actually been done, things that have actually happened. I'll give you some old examples and some new examples, and some examples from different disciplines, and some failures. This is my new favourite example. This is work of Dustin Lang and David Hogg. It's a process by which they've predicted, determined the path of comet homes that flew across the sky in around 2011. But there's something truly remarkable about the way this image of the path of the comet over the sky has been built up. And the thing that's remarkable is that it's built up from images like this. This is an image taken by a member of the North Exeter Astronomy Club through a naked Canon 40D camera. This is not taken through a telescope. It's not taken with any fantastic piece of equipment. The Canon 40D is a pretty fantastic piece of equipment for a photographer, I guess, but I can't afford one. This is an amateur contribution to research data. And for a long time, that's all it would have been. It would have been a nice picture that someone took for their own interest. Because it couldn't compete with what you get from a research instrument like a modern telescope. But what David Hogg and Justin Lang realised was that when you think about the world's best-in-class telescopes, even the ones we're still imagining today, they have an optical sensor area of about 40 square metres. You take up all the cameras in the world, each one maybe has a 1 centimetre sensor area. You have a lot more than 40 square metres, if you can use it. Now it turns out someone is aggregating this data together. That's a service many of you are probably aware of called Flickr. Not a research publisher. This is the result that the researchers got when they did a search of Flickr for comet homes. Up in the top left is Perseus. The comet went through Perseus. The search algorithm here is not terribly good, as it turns out. Obviously, this being the internet, there have to be cats, as you can see on road. However, by applying a framework and an algorithm and a calibration process to the thousands upon thousands of images that they could collect from a public data source contributed by members of the public, they were able to build this composite image that shows the path of the comet. And I'm not going to go through the details. It's a really interesting story. I would encourage you to read the paper. It's on archive. You can read it, freely available. The solid line is the path that they determined that the comet took, purely from an analysis of photos on Flickr. The dotted line is the path as published by the Jet Propulsion Laboratory, best-in-class analysis. And again, we can talk about why they're slightly different. But the bottom line is that scale of data, the large N, combined with the fact that they developed the computational systems that reduced the friction of applying that data to a research problem, allowed them to come close to the best-in-class scientific equipment in terms of determining the path of an astronomical object. Change in the capacity of what we can do when well applied. An older example, and one of my very favourite examples, some of you will probably know Tim Gowers, Professor Sir Timothy Gowers, FRS, KCMG, various other letters, and a Fields medalist. He also is a blogger and he's interested in questions of collaboration. And he posed this question. Mathematics is traditionally done pencil paper in your office away from the world, but is collaborative mathematics possible? And being of an empirical mindset, despite being a mathematician, he proposed an experiment in which he proposed a problem he thought was of interest, a problem to which he thought he might have a solution or a path to a solution. Said, can we collectively, using a combined effort of mathematicians, combine to solve this problem in a way that really hadn't really been done in mathematics before? And the answer was yes. Now, he said it would have taken him 18 months or so to figure out whether his approach was a profitable one, whether it was going to work or not. A group of about 120 mathematicians, some of them world-leading mathematicians, some of them school teachers, contributed various forms of expertise, various particular things they knew about, and solved the problem in 2 weeks by a method different from what he had proposed. In fact, they solved a more general method, a general case of the problem. He goes on to state that it feels this is to normal researchers driving is pushing a car, but the capacity of what they can do has changed. Now the interesting thing is, having had this one big success, they've struggled to actually repeat it. So they found this point where they could change, where they could find this transition. But it's not always the case that doing it over again gets you the same result. And we don't necessarily understand why. Why is it that sometimes we have these successes, and why is it that sometimes we're still struggling along the bottom of that graph, waiting for that transition to occur? Here's a different example. I said I wouldn't talk about access to internet now. This is the only PLOS propaganda in the entire talk. In 2012, we published a paper with about new species of monkey. New species of monkey are things that the broader public is generally interested in. These papers tend to get quite a significant number of views and quite a significant number of interest. This particular paper included some images of the monkey and some audio files, which was part of the reason that there was public interest, because monkeys making funny noises is something that amuses people, but also amuses them in a way that actually brings them into the science. But what I want to talk about is the way that this shifted. So this paper was published on the 12th of September 2012. By the 13th of September 2012, there was a Wikipedia article about this species. That Wikipedia article was populated largely from the PLOS article. It included the audio file and the pictures. This also generated quite a lot of interest. This is actually a significant source of traffic back to the research article. The research articles had maybe tens of thousands, hundreds of thousands of views. That's quite a lot, but it's not, doesn't really compare to things with. This has had millions of views. And some percentage of those people who come to this at Wikipedia then flow on to the research article. A small proportion. But again, at scale, the fact that it's a small proportion doesn't matter. If we have 20 people a month who have an interaction that interests them with a research article, that is 20 people a month who otherwise would not have had that interaction. That is 20 people who might go on to do something more. And that's what's truly exciting about it. So if we think about the way these different examples play out, we might start from a position where we have both very few people involved and a very high friction either to accessing this or to contributing to this. And if you think about reducing that friction, then we maybe be looking at something like the Polymath project. It's still you still have to be a mathematician to be involved. There weren't huge numbers of people. There were orders of magnitude more people involved than for traditional mathematics. We're talking about hundreds, not thousands. But nonetheless, that changed what could be done. If we think about the monkey paper example, we've shifted this from being in a subscription journal where maybe more people read biology journals than maths journals, and maybe these papers are easier to read. And we've basically made it a little bit easier to read by putting it in an open access journal. But what really made the difference, what really created the increase in access, was the fact that it shifted from the journal into Wikipedia. The primary source of information, basically, these days. It is. You know this yourself. You do a Google search for some factual subject. The top hit is from Wikipedia. You're telling me you don't click on that link to start with? And if we think about the comments, we've gone from something where there were lots of people involved, but there was a huge friction for the use of that data because it was all spread across people's hard drives across the world. Flickr, combined with the effort of the researchers, allowed them to integrate that back together, to reduce the friction to engagement with the research, and to allow amateur astronomers to be actually directly contributing to the real science on a day-to-day basis. We would normally think about that kind of end of the graph as the kind of crowdsourcing, public engagement style of research, style of open science. And if we look at the bottom, so we might talk about something different. This is building expert engagement, finding collaborators and building networks that allows us to create greater space. But I want to suggest that actually expert is a very varied term. There are many more experts out there in the wider world than we think of. Again, it doesn't matter that only 0.01% of people are interested in this specific thing. That's still tens of thousands or hundreds of thousands of people at scale. The thing that is changing is the scale we are operating at. And there's also an overlap now. This is increasingly the signature of the most successful crowdsourcing, public engagement / open science, open data, digital humanities projects. They exploit this sweet spot between wider public engagement and crowdsourcing, a passionate community about a specific subject, and increasing the engagement of a range of experts and the ease of interaction between experts and the passionate public. That's where all the benefits rise. Let's show an example of this not working so well, and this does go back to open access. This is a comment from a blog post I wrote a while back. I think I know who this person is, but they were clearly trying to be anonymous, so I'm not going to reveal them, just to say that they are a person who advises ministers in Westminster about public policy. And what they're saying here is something really quite depressing in some ways. They're saying they have easy access to economics papers because those are in existing, well-known repositories where they can find them, where Google finds them, where they can be discovered. But if they want research in anthropology, sociology, psychology, one might add history, philosophy, gender studies in the UK, around discussions around civil unions and homosexual marriage, they can't get access to that. So the only things they include in their policy advice are the economics. And then as scholars, we complain about the fact that policy advice is based purely on economics. There are many different publics to engage: policymakers, educators, professionals, historians, amateur psychologists, amateur archaeologists, amateur astronomers. And we can do better. So what do we need to make this work? As I said, we need to reduce friction, we need to maximise end. There are 3 ways to do that. And here actually I come back to it, really in some ways reinforcing what Stephen was saying. The first of these is access. None of this can be done if the stuff that people can use is not accessible. If it's stuck in the desk drawer, if it's stuck behind a paywall, may as well not exist. And again, you know this. If it's not on the first page of Google hits, it doesn't exist. That means we need to simply default to open access, and it means we need to push for making things available sooner perhaps than they currently are. But this is access to read, to touch. I want to emphasise, and this is perhaps where we part ways, that once that access is in place, we need to ensure that people actually have the legal rights to use things, and for me that means liberal licensing or copyright exceptions or placing things in the public domain. And I would argue that part of the reason that we have struggled to get towards open access, however we define it, is because researchers have not seen the benefits. We have not been able to demonstrate the benefits because simply being able to read doesn't create benefits directly to researchers in many cases, or at least some of the benefits we could create. But there's a third point. That third point is, even if you can access it, even if you can't, if you can legally reuse it, it needs to be technically usable. And again, I think there's a different point here. It's easy to say that all publishers do is manage peer review. And it's certainly, I wouldn't disagree that publishers do more than they need to do. But one of the things that publishers do is make publications interoperable, it's make them consistent and discoverable and format manipulated. Now we need to have a discussion about whether we're prepared to pay for that as a community, whether it's important enough. But that's one example of the kind of technical interoperability that we need for literature, for data, for methods, for materials, for processes, to actually realise this vision. We need better tools. We want to be able to ask different types of questions. We already have several questions about text and data mining. It's no longer enough to be able to read a single paper and find the tree. I don't even want to ask questions about the woods. In my decade as a professional tenured researcher, I can think of a handful of cases where the answer to my question was a particular research paper. Almost never was the actual answer to my question a research paper. It was across the literature. It was a combination of the literature. And again, that's going to be different for different fields and different disciplines and different backgrounds. We need to create the platforms to support innovation. We need to use the fact that people are doing searching and leaving trails behind them to make it easier for other people to create trails. The example of the Wikipedia article is one example of that kind of trail. To create collaborative collections that enhance discovery, enhance interoperability, and we need to build the networks that make this work. So, if I finish, stop doing that, by returning this question of what does being open mean, and for me, it's part of a philosophical acceptance that we don't actually know all the answers. Accepting the point that no single person has the answers, and this is the advantage that we have today, that we have the ability to make better connections and more connections. We need to use the network systems, the infrastructure we have to make this work better. We need to engineer our systems so that they scale to take advantage of those bigger ends. We need to engineer them for interoperability, both legal and technical. And we need to engineer them to reduce the friction and to build in the opportunities for serendipity so the work can go where it needs and what you need can find you. And my point is we can tackle different aspects of this in different places. We don't need to think of this as a step-by-step approach. There are opportunities and advantages that we can take by taking different elements of this in the places where we have the opportunities available to us. We don't need all of access to everything before making some progress on the legal issues. We don't need either, because we can already make a lot of progress on the technical interoperability of data that is already available or should be according to agreements people have already signed. At the end of the day, the argument for the web, the argument for open science, is that between us we may have the answers. So when it comes to the question for me of what open science is, it's just actually using the infrastructure and technology and systems available to us to do better. And that's right there. Thank you.
Thank you very much. And now there is time for questions. No questions. They are overwhelmed. Oh, which one?
My name is Marcin Zarot from Institute of Sociology, University of Warsaw. I strongly endorse your communicate, and I will strongly to add that maybe for some guests from foreign countries, from abroad, it's worth noticing that the first citizen science project in Poland was done by astronomer. So this kind of amateur approach or citizen science approach maybe is somewhat connected to this field, but it actually covers archaeological exploration. It's called Laser Explorers or Laserowi Odkrywcy, and it focuses on community-based analysis of air pictures of archaeological data. And it started a few months ago, so if you are looking for local cases or you wish to explore local projects in your educational or any other analytical needs, it already exists. It's somewhat based on Galaxy Zoo concept, but it's also better prepared to interlink with Polish educational program. So
I think it's worth making the point really explicit that there are opportunities out there for people to do research with a global reach, with global impacts, and get, as people want about this, the publicity that will help increase funding and get your discipline or your institution a higher profile. If you're smart about where the opportunities lie, the global solution does require global access, then global legal rights, then global technological interoperability. But there are places where all those leaders will have to make a big difference today.
And thank you very much, Cameron. And if I may give an example from digital humanities rather than science, and that at the other conference yesterday I made some reference to some digital humanities projects. One which I might refer to again is where efforts have been made to put an infrastructure together describing how survivors of World War I were treated in different societies, whether they were victors in the war or defeated in the war, how injured people were treated, what pensions were provided, housing, etc., etc. And projects of this kind attract an enormous public interest. But we need a fourth thing besides the three that Cameron mentioned: access, legal rights, and technical usability. The fourth is, once the public become engaged, once the infrastructure is put in place, the public are invited to have access to it, then they begin to give narratives relating to their own personal experiences. And therefore the infrastructure has to be updated. And the PIs who have been responsible for bringing it together in the first instance really have to continue to be funded after the initial creation is there. And if the funding ceases, the public become frustrated. They're sending effectively messages in, my grandfather was treated in an abominable way, etc., etc., and that is not being recorded at all. And I would think that anything that attempts at open science in the same way must have continued funding after the creation is there, so that the lay public out there making contribution to knowledge will have their contribution recorded in some way. And that is a factor of continuing cost, which is, I don't think, a problem that anybody has addressed for any of these infrastructures.
So it's a really good point. I thought you were going to make a slightly different point, but that sustainability issue, engagement and continuing engagement. I mean, we talked a little bit yesterday about the nature of the social contract for scholarship and research in the 21st century, and it is clear that if we seek engagement purely as a mechanism to justify public funding for research and scholarship, and don't back that up with a real commitment to engagement. Again, I'll go back to science examples, but Galaxy Zoo is a wonderful example of where researchers have created an infrastructure that allows people to contribute their efforts in recognising images. But going one step further, has started to do real science based on what those people have recognised as unusual things in those images. The classic case being Hanny Holder's green peas, but there are actually a series of examples now. And that sustainability question, I mean, one of the things that's perhaps a little depressing is that some of the most successful projects in space have not come from the research community, they've come from the public. And the public have been sustaining them. The interested community have been sustaining them. And I would absolutely agree, we need to think very carefully about building sustainability into an infrastructure that supports that sustainability over time, if we're serious about utilising those resources.
Professor Henry, please.
The same point, but a different aspect of it. It's also about sustainability and scalability. But you said that when Tim Gowers' crowdsourcing proof experiment was done, it produced spectacular results the first time and not so good the second. That may not be a sustainability issue. That may, in fact, be a Hawthorne effect. Do you want to explain?
Yeah, so the notion, I mean, so there's a series of discussions around, so sometimes when you do something the first time, it gets interest because it's the first time, because it's new, and that drives engagement. It is also the case that sometimes when you do things repeatedly, you overthink them the second time because you think you understand what happened. So the question to my mind is, what can we learn from both the successes and failures? And perhaps the lack of sustainability. So I don't think it was a sustainability issue in the case of the Polymath project, because again, it was done with blogs and wikis, basically, essentially free. The question is the frameworks that were created to solve a particular problem, was it the nature of the problem, was it the nature of the interest? Sometimes it's just luck. Sometimes the whole point of this is at scale. You use the luck, because if you have a 1% chance and you do things properly, you can figure things properly, and you should ensure that you can figure things properly to maximise the chance that the good result comes, having the portfolio.
That's also how you win the lottery, but it's not a good strategy.
No, it's not. Well, so yeah, and winning a lottery is exactly the kind of thing we shouldn't be doing. So what we should be doing is deliberate. I've got another set of slides which I didn't use where I talk about an analogy from rolling dice. So if I rolled 2 dice and asked you to tell me what the sum was, the ones that give you no probability would guess 7, and you'd still get that wrong half the time, right? If I roll that dice, those 2 dice over and over and over again, we know exactly what the distribution is. And my point is, we have the opportunity to build and to load the dice. And that's what we should be doing. We shouldn't be expecting success every time. We should be designing to maximise the opportunities for success. And that's true whether we're talking about a single research project, a funding organisation thinking about what it funds, or if we need to experiment and ask questions and get more data in about which different paths we want to take, we need to think about how we resource those different paths effectively so as to make sure we maximise the information, maximise the chances of success.
Over there.
Thank you very much, Mr. Walter from the German Research Foundation. I was very pleased with your talk. Thank you very much. I very much support also the development that you sketched and seeing the additional benefits that are really intrinsic to the interests of science and the networking, the efficiency, the reach, the outreach that you sketched. But the question that I have, when looking at this vision of an open science system, how do you envision the change of roles and responsibilities in the system for sustainably creating and maintaining the system. And we refer now to the tasks that we see before us. How are there new roles basically in the system? How do we conceive of the traditional sciences? Do publishers, research funders have to take on new tasks? How do you see the relationship in this regard?
Okay, that's a big question. Let me try and tease out some of the simple things and maybe then direct towards more complex things. The first thing we need to do is align and maybe tweak researcher incentives so as to maximise the interest that individual researchers have in adopting these approaches where they make a difference and where they see them making a difference. The simplest route in my mind to doing that is shifting slightly from the way we currently assess people to ask questions, not to stop counting outputs. That's the basic premise. Stop counting outputs, start measuring the use of those outputs. So start asking the question, how many citations have you had? How many people have looked at this research? How many people have used this data set? How many people have used the source code you created? Now, we have an opportunity to answer or at least get proxies for some of those things. It's not perfect, there's lots of work to be done. But there's a very subtle shift there. It's already happening. The move from I have a paper in Cell to I have an age index of 36 is already a move away from where I publish to how many citations I have. How much is my research being used by other scholars? All we need to do is push that a little bit further, say, yeah, we want to know about how your research is being used by other scholars, what's your influence. We want to know about how your research is reaching out into other populations and communities, maybe professional users of your research, if you're in primary health research. How many nurses are talking about your work on primary care? How many teachers are using your work on education? Those kinds of questions. And again, we can start with social network analysis and social media analysis to get an answer to that. If we shift that emphasis slightly from I have a very long CV to I can show you the top things and how they're being used, why they're being used, then you change the incentive to, I just need to get that thing out of the door to the highest prestige journal I can get to. I need to configure this output so as to make sure it reaches the maximum number of people in the most useful way possible. Suddenly it's in my interests to shift that thinking away from, I just need to read this journal to, I should put the data in as well, because that would be helpful, because people might use it and that might increase the citations, or it might mean someone in another discipline uses that data. So that shift is a very powerful one. It's one that's already underway. All I'm suggesting is pushing it a little bit further along the same policy agenda of transparency and public engagement we already have. The bigger questions are the different stakeholders and how they play. Again, we need to look at the incentives in the current system, which are in many ways perverse. How can we tweak those incentives so that they work more effectively? Can we unbundle, as Stephen was saying, the services involved in publication so that we have real competition at different parts of the stack and drive real innovation and real cost savings? How do we get institutions to be a little less insular, perhaps, about their own interests and look at themselves as part of a wider community of engagement? There's a very interesting, the president of the University of Arizona has this very interesting thing he says, which is, what if I no longer define the success of my institution by how exclusive we are, but as how inclusive we are? And I don't know how you, aside from the exceptional individuals who take that stance, I don't know how you create incentives at an institutional level, but that's the other kinds of things we need to do. We need to, you don't change culture overnight. You don't change systems overnight. You don't change the way people think very easily. You can get people to act in their own self-interest, and you can tweak the incentive systems if you're smart about it and clever about it, so as to drive the kinds of behaviour that hopefully takes the right direction.
Thank you very much once more, and we will go on to the next lecture. Thank you.